this is Mrs. Often, and today I'm really excited because I'm going to talk about some of my favorite stuff, and that is counting stuff. We're going to talk about the fundamental counting principle, we're going to talk about permutations with repeated elements, and about combinations. So the first thing I want to talk about is the fundamental counting principle. The fundamental counting principle says if event E1 can occur in M1 ways, and event E2 can occur in M2 ways, then E1 and E2, if they occur together, we can find the number of ways by multiplying M1 times M2. So this basically means that you find the number of ways the first event can occur, the number of ways the second event can occur, and multiply those two numbers together. If you have 3 or 4 or 5 events, it just increases the number of numbers that you are multiplying together. So here's our question. How many 3 different 3-digit codes can be made if the first digit cannot be 0 or 1? So I'm going to draw 3 lines here to indicate my 3 different digits. Now this does not say that we cannot have repeated codes, so I could have 222 or 333. I could not have 000 because the first digit cannot be 0 or 1. So how many choices do I have for the first digit? Well, I can pick any number or any digit from 2 through 9. So that's a total of 8 different choices. For the second digit, I can pick any digit 0 through 9. So that's 10 different choices. And for my third digit, I can pick any digit 0 through 9. So that is again 10 different choices. So I'll have 8 times 10 times 10, or 800 different codes. An interesting extension that we'll look at in class is what happens when we can't have repeated values. Permutations are an ordered arrangement of items. So when you think, does order matter, like places in a race, prizes that people get, then you want to use a permutation. And we usually have keys in our calculator for this, NPR. This calculates n factorial divided by n minus r factorial. So here's our example story. Andrew will line up 5 of his 8 stolen Bugattis at the car show. How many different ways can this be done? Well, we're going to assume that all of Andrew's Bugattis are different looking. Because why would you steal duplicates of the same car? So I have 8 total cars, and he's going to pick 5 of them. So this is going to be 8 factorial divided by 8 minus 5, or 3 factorial. And you should be able to calculate this directly using your calculator. I'm stuck in the unfortunate position right now of doing this by hand. So it's 8 times 7 times 6 times 5 times 4. Because it cancels out with 3, 2, 1 in the denominator. Fortunately, that's 6. So I'll have 35 times 32. I'm just going to sketch this over here. And that gives us 1,120 different ways that he can line up 5 of his 8 stolen vehicles. So that's permutations. Order matters. Now sometimes, let's say that some of those Bugattis look the same, then we would have to consider a permutation with repeated elements. How many different ways can you arrange the letters in cheesecake? Well, I could just say, oh, well, this is 11, how many items is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters in cheesecake, and I can just arrange 10 letters taken 10 at a time, 10p10. But that's going to give me too many answers, because look what happens if I switch the order of these two E's. cheesecake. It looks exactly the same. So I need to consider my different elements here. So I have 10 items. Out of those items, I have 1, 2, 3, 4 E's and 2 C's. So for my permutation, I'm going to have 10 factorial divided by 4 factorial times 2 factorial. The 4 factorial is for the E's, and the 2 factorial is for the C's. So this is going to be 10 times 9 times 8 times 7 times 6 times 5, all divided by 2 factorial, which is just 2. So I have 72 times 42, and that is 3034, and then I'll multiply that by 25.
Sure.
To multiply by 25 quickly, I just multiply by 100 and divide by 4. So that's 75850. Okay, this would be a lot smaller than just doing 10 factorial because, as you can see, I cut out all of that 4, 3, 2, 1, and then divided by 2. So this is much fewer permutations because the repeated letters make things look like they've repeated. Okay, so this is permutations with repeated elements. And you don't have to use NPR, you can just use this formula for it. Now, if order does not matter, then we have something called a combination. I remember this as being like a combination platter at the Chinese restaurant. I don't really care what order they put the food on in, as long as I get all of the food that I've ordered. So, we see here the binomial coefficient showing up again, NCR, or NR, and that formula that you've seen in other videos, n factorial divided by n minus r factorial times r factorial. So here's our question. How many ways can I choose 3 of my 10 math books to take to the conference? Well, this is 10, and I'm going to choose 3. Now, it doesn't matter what order they're in, because I'm just going to throw them in my suitcase and take them along. So I have 10 factorial, again, a huge number. I'm going to divide this by n minus r, so 10 minus 3 is 7 factorial, and then 3 factorial. Now what that 3 factorial is doing is it's reducing out the duplicates I would get from considering, hey, order matters. Because here, order does not matter. So now I just need to evaluate. And so I'm going to have 10, 9 times 8 over 3 factorial. That's 3 times 2 times 1. So this is 10 factorial divided by 7 factorial. And then I'm just going to do some reducing. So 10 times 3 is 30, times 4 is 120. So overall, I can choose 120 different ways. Okay. So that's a combination problem. You can see from the description that order does not matter, and so I use NCR, which is like NPR, but has that extra term in the denominator, that extra r factorial. Okay. Finally, we'll look at a more complex example. A committee must have 3 men and 3 women. If there are 6 men and 4 women, how many ways can the committee be formed? Well, this has 2 events. Our first event is that we need to pick our 3 men to be in the committee. Our second event is going to be picking 3 women. Now the order in which these events, honestly, it doesn't matter what order we do them in. And it doesn't matter what order people show up in because this is a committee. It's not like there's vice president and treasurer and secretary. So I'm going to use NCR because order will not matter. And since there are 2 events, the selection of the men and the selection of the women, I'm going to multiply those 2 things together at the end. So I have 6 men, and I'm going to choose 3. Then I have 6 women, and I'm going to choose 4. So so there's my calculations so far. And I know the second one is 15. And 6 factorial divided by 3 factorial divided by 3 factorial again is going to be 5 factorial over 3 factorial, which is 20. So 20 times 15 is going to be 300. So there's 300 different ways in which that committee could be formed. And maybe that's why it's so hard to get anything done when working by committee. So those are your different ways of counting things. You have the fundamental counting principle, take the number of ways one event can occur, the number of ways the second event can occur, and multiply them together. You have permutations, where the order matters. You have permutations with repeated elements, slightly different formula. And you have combinations, where the order does not matter. We'll be going on to use this method of counting when we talk about probability. Thanks, and have a great day.